Section 4.2. You guys should know that when you have an equation for position, yeah, it's whatever mx plus b, for example. If you derive this once, this will be your velocity, and if you derive your velocity, you get the acceleration. Okay, you use the equations when they want instantaneous. Okay, whether they're asking for instantaneous velocity, instantaneous acceleration. If they're asking for instantaneous, you use the equations. If they're asking for the average, okay, so that means they're asking from like a time interval from time 2 to 3. Yeah, if they're asking something like this, that means you need to use, like, for velocity, that's position 2 minus position 1 over time 2 minus time 1. And for the acceleration, that's velocity 2 minus velocity 1 over time 2 minus time 1. Okay, just a reminder. Let's start. Number 1, they're asking for the position of a particle when they gave you the equation of its position at time 2. They want the velocity, okay, they want the velocity at time 2. Yeah, they gave us the position here, and to get the velocity, we're just gonna derive this once. That would be 4t to the power 3 minus 6t. Okay, and they told you that they want it when time is 2, so you just come here and substitute 2. 2 minus 6, 22. In the end, you get 20. That's your answer. Number 2, the displacement of a particle moving along the x-axis is given by this equation. The average acceleration from time 1 to 3 is blank. Okay, for this question, they're asking for the average acceleration. Remember, we said the average acceleration would be the velocity 2 minus velocity 1 over time 2 minus time 1. Okay, so that means that we need to find the velocity. So to find the velocity, we're gonna derive this equation. So you get 1t cubed minus 16t. So it means this is just t cubed. Okay, so now you have the equation for velocity, and they want the acceleration from time 1 to time 3. So that means the acceleration is equals to the velocity at times 3 minus velocity at time 1 over 3 minus 1. Yeah, so we're just gonna take 3 and substitute it into the velocity. So velocity of 3 is gonna be 3 cubed minus 16 into 3, and the same thing for 1. So v1 equals to 1 cubed minus 16 into 1. So here you get minus 21, and here you get minus 15. So now we put this back into our equation, so it's minus 21 minus minus 15 over 3 minus 1. In the end, you get minus 3. And that's our final answer. Number 3, the displacement of a particle moving along the x-axis is given by this equation, and they want the acceleration at time 2. Okay, to get the acceleration, they're asking here for at a specific time, so this is instantaneous. So we're going to use the equation. So first we go through velocity, we derive once, so it's so the velocity is equal to 2t to the power 5 minus 8t cubed, and if we derive one more, we get the acceleration, so it's 10t to the power 4 minus 24t squared. Okay, they told you at time is 2, so you just take 2 and substitute it into this equation. So acceleration at time 2 is 10 into 2 to the power 4 minus 24 into 2 squared. You get 64. Number 4, the position of a particle moving along the x-axis is given by an equation. The particle is at the origin when t is blank. Okay, when a particle is at the origin, something's at the origin, that means its position is 0. It's where it started, صح? And here we have already the equation for position. So we're just going to equate that to 0. So 0 equals to 3t minus 15. So that means 3t equals to 15. We'll just move 15 here. So that means t is equals to 5. Number 5, the position of a particle moving along the x-axis is given by an equation. The particle is at rest when time is blank. Okay, this is the same thing. So they want the velocity at rest, right? When it's at rest means it's not moving. So that means our velocity is equals to 0. So now we need to get the equation for velocity. So we're going to derive. So the velocity is going to be 6t minus 12. Okay, equate this to 0. 6t minus 12. So that means you get 6t equals to 12 and t equals to 2. That's our answer.